So here is question number 6, everyone. Two stationary sources A and B produces sound of same frequency. A person running from A to B with constant speed hear 5 beats per second. If the frequency of each source decreases by 100 Hz, then 3 beats per second is heard. Then the original frequency of each sound will be what? According to the question, source A, source B, and here is the person moving from A to B with speed V0. Now, frequency of the sound observed by observer coming from A will be Fa, given as, according to Doppler effect, F0 actual frequency, V minus V0 upon V, where V is the speed of sound, V0 is the speed of observer. Similarly, frequency from sound B observed by observer given as Fb, that is F0 V plus V0 upon V, where same V is speed of sound, V0 is speed of observer. Now the beat frequency can be write Fb minus of Fa, that is given in the question 5. Fb minus Fa, when we'll do it, we will get 2 F0 V0 upon V, equation number 1. Similarly, we can write the expression for decreased frequency, that is 100 Hz. Observed frequencies are Fb dash minus Fa dash. Fb dash and Fa dash are observed frequency. New beat frequency will be this, which is equal to 3 according to question, and can be written as 2 times actual frequency decreased by 100. So F0 minus 100 V0 upon V, equation number 2. Taking the ratio of 1 and 2, what we are going to get? Fb minus Fa upon Fb dash minus Fa dash equals 5 by 3, further equals F0 upon F0 minus 100. Now we have to solve this and calculate F0. After solving this, we'll get the value of F0 as 250 Hz. So option number 4 is we can go with proper answer. Now move on to the next, that is 7 number. A narrow slit of width 1.2 into 10 to the power minus 6 meter is illuminated by a parallel beam of light of wavelength 6000 angstrom. Incident normally on it. The angular width of central maximum will be what? We know very well the angular width given by twice of theta. Now this theta we can calculate. We know very well sine theta given as lambda by A. Putting the value lambda 6000 into 10 to the power minus 10 meter upon A 1.2 into 10 to the power minus 6. After solving, we will get this 1 by 2. From here we will get the value of theta, that is sine inverse 1 by 2 or sine inverse 0.5. So angular width, that is 2 into theta, so 2 sine inverse 0.5. Option number 3 is absolutely correct, so we will go with option number 3 only. Now move on to the next, that is 8 number. Here is question number 8, everyone. The thickness of half wave plate for an electromagnetic wave of wavelength lambda equals 9000 angstrom will be, where refractive index of ordinary light is mu naught equals 1.5533 and refractive index of extraordinary light is mu e given by 1.5443. We know very well the path difference between two lights is given by mu naught t minus mu e t, where mu naught ordinary light wavelength, mu e extraordinary light wavelength. On the other hand, for half wave plate, the path difference is written as for half wave plate, path difference delta x is what? Lambda by 2. Equation 1, equation 2. We can equate them now. So lambda by 2 equals mu naught minus mu e into t. Therefore we'll get the value of t further, lambda upon 2 times mu naught minus mu e. Putting the values, lambda 9000 into 10 to the power minus 10 to 1.5533 minus 1.5443 gets you 0.0090. After solving it, we'll get the value of t as 50 into 10 to the power minus 6 or 50 micron. So option number 1 we can go with. Absolutely correct. Now move on to the next, that is 9 number. So here is question number 9, everyone. In Young's double slit experiment, the fringe pattern is observed on the screen placed at a distance capital D. The slits are illuminated by the light of wavelength lambda. The minimum distance from the central point of screen where intensity becomes 3/4 of maxima is what? Intensity and phase difference are related by IR equals 4I naught cos square phi by 2, where phi is the phase difference. Now IR is what? 3/4 of maximum intensity, that is 3/4 of 4I naught equals 4I naught cos square phi by 2. 4 cancel out, I naught cancel out. We'll get 3/4 equals cos square phi by 2. From here we get the value of phi by 2 as cos inverse under root 3/2, that is 30 degree. Phase difference phi we have got 60 degree. Now let's calculate the path difference. We know very well path difference delta x is given by lambda upon 2 pi into phase difference. 60 we can write it pi by 3 as well. Pi cancel. Path difference, that is lambda by 6. Now path difference expression can be given as yd upon capital D, that is lambda by 6 calculated. From here we'll get the value of y, distance from the central maxima, that is lambda capital D upon 6 small t. So we can go with option number 4, which is absolutely correct. Now move on to the next, that is 10 number. So here is question number 10, everyone. A block of mass 2 kg is connected with 3 springs A, B and C having spring constants 100 Newton per meter, 100 Newton per meter and 200 Newton per meter respectively, is placed on a rough inclined plane having coefficient of friction mu equals 0.2 and angle of inclination 53 degree as shown in figure. If initially all the spring are in natural length and block is released from rest, then the maximum potential energy stored in the spring A will be nearly, take G as 10 meter per second square. Question can be solved using work energy equation. We know very well work done by conservative forces plus work done by non-conservative forces plus work done by any external force. This total sum means work done by all the forces will be what? Change in kinetic energy, which is here start from rest, end to rest, 0. Now work done by conservative force can be written as negative of change in potential energy plus work done by non-conservative, which is friction here. So work done by friction, there is no external force, so this term goes to 0 equals 0. Now let's do it. Now minus of, what are the changes in potential energy? Moving down, the block will reduce its potential energy if it is coming down by a height h. This is the initial position of block, this is the final position, and this is the height by which it is reduced. This is the distance x, angle 53 degree. Therefore we can write minus mgh, decrease in potential energy. Now there are increase in potential energy as well because the spring is compressed. Potential energy will be stored in A, will be stored in B, will be stored in C, such that half Ka x square plus half Kb x square plus half Kc x square. X will be same for all the springs. Work done by friction will be of negative nature, so minus mu mg cos theta, that is cos 53 degree, multiplied by distance it is moved, that is x, which is equal to 0. Rearranging and solving it gets us half kx square. Putting the value half, k is 100, x square, x we have to calculate, plus half kb is also 100, x square, plus half kc is 200 into x square, plus mu mg cos 53 degree. Mu mg cos 53 degree will be equal to what? mgh. Now this h will be what? X sine 53 degree. Putting here x sine 53 degree. X term we have missed here, so multiplied by x. Now we have to solve this particular equation, and after solving it, what we will get? After solving, we will get x as 0.068 meter. So this is the value of x we will get after solving, and once x is solved, we can calculate the potential energy stored in A, PEA, that is half k into x square, and which comes about 0.2 joule. So 0.2 joule is our final answer, and we can go with option number 3, which is absolutely correct. Now move on to the next, that is 11 number.